Good morning and welcome everybody for the last Red Couch interview for this year's PCIM. My name is Michael Brunner, I'm the editor-in-chief of the EMEA magazine, and we had a lot of interviews with important people during the whole trade show. And you can watch us live here at the trade show or via YouTube and our Facebook channel. And right now I would like to welcome Stephan Greiner, Vice President EMEA from Cree, and we will talk about innovations in SiC-MOSFETs. Welcome.
Hello, thank you very much for having me.
Herr Greiner, silicon carbide has become an alternative to silicon. Which developments are responsible for that?
Well, the main driver for that was simply the requirement to increase efficiency of the systems. So energy efficiency is, well, sign of the times, and that's a main driver for silicon carbide. It started with the Schottky diodes, bringing them into the system, and well, I think the Schottky diodes build a reputation for the reliability of the technology, and that's leading also towards more and more silicon carbide acceptance. Well, and the trends to higher voltages is driving silicon to the limits, and is also driving a requirement for silicon carbide. And I would say a main driver for the current momentum is simply that silicon carbide now, with performance and cost, reaches the target areas of the developers. So that all in combination is the reason why silicon carbide is coming with such a power now into the market.
So what are the main benefits of silicon carbide in comparison to silicon?
Well, certainly the higher switching frequencies are a main advantage, and with that in combination the reduction of switching losses, that's definitely a key. The higher possible voltages, the higher power density, higher current density is definitely are definitely big advantages for the technology, and all that in combination allows the designers to reduce material in the systems and to bring the overall BOM costs down.
So if we have so many advantages, shouldn't a silicon carbide replace silicon completely? And will it maybe one day?
Well, we believe that in voltage ranges above 600 volt, that could be answered with a yes. Below, certainly not. But in higher voltage ranges, we believe that'll happen, yes.
Are there any specific power electronic components for which SiC is particularly suitable?
Well, from our point of view, that what we are currently offering, that's basically Schottky diodes in the ranges of 600 to 1700 volts, and also the power MOSFETs in the ranges above 600 volts. That's what we mainly see also for the future as the playing field for silicon carbide components.
So what are the main application areas for power electronics on the basis of SiC at the moment, and which application areas will appear in the next few years?
Well, main application fields currently are power supplies, universal power supplies, switched mode power supplies, as well as solar inverters. What currently is at the edge of implementation is motor drive applications. Also, electro-vehicle charging is coming up issue now, and a little bit further down the road also transportation, traction, like trains, Caterpillar drives, things like that.
So are there any areas where you won't use it? Doesn't sound like that.
Well, I would say all low power driven areas are, well, you don't really have advantages in using silicon carbide for lower power.
Like in consumer electronics, for example, it doesn't make any sense.
Not really, no.
So talking about your products, which new products on the basis of SiC will Cree launch in the future? Give us a short view on your roadmap.
Well, we just, with the fair here, announced our new 50 amp MOSFETs and Schottky diodes, the MOSFETs for the 1200 and 1700 volt range. We think that's definitely leading edge currently. So, well, of course, we want to stabilize that technology, bring it in the market, and we will certainly focus on developments below 1200 volt, between 600 and 1200 volt on the MOSFET side, and well, we could also imagine to go into developments above 1700 volts. So that's the main direction.
We've seen through the trade show a lot of companies having products with based on silicon carbide right now. What do you think makes the difference? Where is Cree better than the others?
That's a very dangerous question, of course. Well, you should never talk bad about others. I think everybody here that you can see here at the fair is doing a very good job. We think we are leading because for us silicon carbide is really the key focus. Cree is and has always been a silicon carbide company. I don't know how much that is known, but all our LED components are also based on silicon carbide technology. That means for us that's really the key focus, and well, based on that we believe that we simply have the best IP in that technology.
And a lot of experience.
And a lot of experience, certainly, and a lot of scale, which is also very important. Means manufacturing scale and optimization potential driven through the other product areas too.
Okay, that already was it. Thank you very much.
Okay, very nice, very quick.
Ladies and gentlemen, this was the Red Couch talk about innovations in SiC-MOSFETs live from the PCIM trade show. Herr Greiner, thank you very much for being our guest this morning.
Thanks very much for having me.
Thank you everybody for watching and listening, and if you are interested you can find this interview and all the other Red Couch talks on Published Industries YouTube channel. Thank you very much.